So now that we've got this nicely modeled environment here with this sculpted riverbed area, let's go ahead and create some rocks and instance those throughout this river region. So I'm just going to start by building just some really basic procedural shapes for these rocks. Just create a sphere, zoom in on that, and we're going to make this a polygon. I prefer the polygon over the polygon mesh because the polygon mesh wireframe layout is not quite as nice as the standard polygon. And this low resolution sphere is totally fine for now because the first step here is to just get a sense of general shape for one of these rocks. So let's create a mountain sop and we'll give this a big height. Let's try 10 and an element size of 3 to get larger noise features. And this looks awful. This is a very distorted shape, but it doesn't really matter because we're going to be turning this into a volume and then creating a nice smoother shape based on this. If you go really conservative with the heights here, then your rock shapes might not be different enough from each other. And even though this looks terrible and extreme, you'll see in a moment how this will get smoothed out. Now we're also going to be using different frames on our timeline to create different rock variations. So let's display the timeline, and in the time parameter of the mountain, I'll type @frame and I'll give it a multiplier of 10. So now as we switch frame to frame, you can see we're getting some drastically different shapes for these rocks. And these sizes are also drastically changing on every frame. So I'm going to use the match size sop, hook that up to the mountain, and we'll use this scale to fit option here to force this down to a specific size. So in this case, maybe I'll make the size 3 units on each axis. And if we show that, you'll see it kind of makes these shapes all very square, and it kind of ruins some of the variation that we want. So I'll turn on uniform scale so that it just picks the best overall, size scaling, and it without distorting the actual shapes. So you can see this one is not stretching out the Y dimension to fill the box. We want to make sure this is just a uniform scale. And now to smooth out this kind of messy polygon into a better shape, let's convert this to VDBs. So we'll use VDB from polygons, and this could work fine, might not be quite enough resolution. I'll make that a little bit higher res there. And then we can smooth this out with the VDB Smooth SDF. So if we display that, you can see that's getting quite rounded out. Maybe it's a little bit more smoothed out than we need though. So I'll just reduce this down to 1 just for a little bit of extra smoothing, just to kind of tame some of those edges. So then we can convert this back to polygons. Just do convert VDB, set this to convert to polygons. And now if we step through some of these frames, you can see we have some interesting initial shapes for these rocks. It still doesn't look very nice and natural yet though, so let's add some more mountain noise. Let's display that, and we can go a little bit more subtle with the noise at this point. Doesn't have to be nearly as extreme. So let's try something like this. Look at a few examples, and this is starting to look a little bit nicer. Maybe let's try looking at it smooth shaded so that we're not quite as biased by the wireframe there. And yeah, this is starting to look like a reasonable procedural rock. And you can also experiment on some of these mountain sops with some other noise types. Like I think sometimes for rock shapes, I'll use one of these Manhattan Worley noises. Those can look pretty good. Maybe not that one. But yeah, this one's looking pretty cool. I think I like that a little bit more than the default simplex for this extra layer of detail. And right now this doesn't have any normals on it, and it's good practice to always include some normals on your geometry. So let's just add a normal sop, And let's pack up this geometry before we cache it out to disk. Just drop in a pack sop, and you can give this a descriptive path if you'd like. This is really helpful if you wind up with a bunch of different types of geometry all merged together in a cache or something. It's always good to be descriptive on your paths. I'll just set this path to rock_instances. And actually, before we pack this, I'm just going to do a little bit more of a size normalization. Let's drop another match size in here. And I'm going to scale these down to be 1 unit in size with a uniform scale. And having this nice uniform scale of 1 is really going to be helpful to give us extra control over the distribution of sizes when we do our instancing. If you have your instances all different sizes, it's much more difficult to control that distribution later. And now that we have these unique rocks on each frame here, we can accumulate a handful of them to use for instancing. And one way to accumulate a bunch of these is to use a trail sop. Let's drop that down. And on this trail sop, you can use the trail length parameter to define how many copies of these rocks you want. So let's say we want 20 instances. If you put a trail length of 20 in there, you can see we're getting 20 variations of the rock all stacked on top of each other. And often in Houdini, we want to kind of separate lots of elements to see them more clearly. And in many cases, the exploded view is really effective for that. But because all of these pieces all have the same center point at the origin, the exploded view isn't going to do anything. So whenever we have a bunch of packed pieces with the same, centroid at the origin, I like to use a point jitter to push all of these variations apart so that we can get a better look at them. And there you go. We have a bunch of interesting looking rocks here. I think that looks pretty good. And if you want to pick a different subset of these rocks, you can just change the frame that we're doing our trailing from. So right now we're on frame 3, and if we change frames here, you'll see that we get a different set of rocks every time. But ultimately, we don't want this to be changing every frame of our timeline. We want to just pick one frame to do this trail here. So I'm just going to add a time shift and Control-Shift-Click the frame parameter to get rid of the expression there, because by default it'll just follow the current frame. And now we can pick which variation of the rocks we want by changing the frame that we're freezing this at. I think this set of rocks looks pretty good, so I'm going to stick with that. And of course, let's drop in a null that we can use to keep our scene organized. We'll call this instances high res. And now that we have all of our rock instances picked out, let's cache these to disk. Just drop in a file cache sop. I'll point this to my instances folder, maybe version up from my old rock instances. And for the start and end frames, we want this to match what we've calculated with our trail and our time shift. So because this trail sop is looking back 20 frames based on this parameter here, we want our cache to, end at this time shift frame here and run for 20 frames prior. So let's copy the frame number in this time shift. Right click, copy parameter. Let's put that in the end range here. And I'll also paste it into the start. So now we have its start and end frame of 1, but then we can just subtract the trail length from the trail sop there. So I'll right click, copy that trail length parameter, go to the start frame here and say it's the time shift frame minus, and then we can paste relative references again for that trail length. So now this cache is running from frame -19 to frame 1. So I'll turn on load from disk, which will of course error until we actually save these out. Now these rocks are quite high resolution and we can't see the wireframe anymore. when these are packed like this, but you can go into your display options, geometry tab, and turn on wire over packed geometry if you want to see that. And you can see, yeah, these are really dense. And you don't really need to have that level of resolution when the rocks are further away. Like, you know, at this distance, it's really not worth having really high-res rocks. And if you find these are a bit heavy to work with, then you can absolutely feel free to swap in some different rocks. And it doesn't hurt to have a couple different levels of detail saved out. So we can drop in a remesh. Let's connect the match size on this rock to this remesh SOP, like so. That's perhaps a little bit too low resolution. We could, change this target size a little bit to add some more detail. And you can see now this is 626 polygons instead of 11,494. And in my scene, I just used the really high-res ones because my machine seemed to handle it okay. But certainly feel free to save out a low-resolution version as well if you would like. And then depending on the needs of the shot, you can feel free to switch between them. Now with our rocks built here, we're almost ready to start the actual instancing in the riverbed. Just going to do a couple more things. I'm going to use an assemble SOP to create unique names on all of these individual rocks here. I'll rename that to unique names, and the output prefix will just be rock underscore. And if you look at the spreadsheet and look at the prims, you can see each of these rocks has a unique name. It's just good practice. And then finally, on this file cache here, we're going to go to the Load from File tab, and under Load here, I'm going to tell this to use packed disk primitives. And this is really going to help us with efficient instancing, both within Houdini and in Redshift. And I'll talk more about these packed disk primitives as we get more into the instancing process, which we'll take a look at next, and we'll also talk about it more when we get into the Redshift rendering. And one more quick note before finishing up this video. You'll notice that when you set this to load packed disk primitives, by default this will display as bounding box. And you can change that display setting here to full geometry, or anytime you have bounding box displays to your viewport, you can also use a packed edit SOP to change the display type in SOPs as well. So if you hook that up here, change display as full geometry, and you can play around with the other options here as well if you'd like. But for now, I'm just going to leave this as displaying full geometry as set on this file cache SOP directly. And sometimes you might run into cases where Houdini is forcing a bounding box display in the viewport if you're running into really heavy scenes. And you probably won't run into this very often, but if you bring up your display options and go to Optimize, you can change this distance-based packed geometry calling. You can change the polygon threshold when it starts displaying bounding boxes. You could try turning that off entirely. And yeah, in those more rare cases where scenes get crazy heavy, you might find yourself needing to play around with these options a little bit.